Lesson 2.4 is about factoring and solving polynomial equations. One thing to know when we are factoring polynomial equations is that we want to try to find prime polynomials. Prime polynomials is a polynomial with two or more terms that cannot be written as a product of polynomials of lesser degrees. What that means is an example of 4x squared minus x plus 2. When you look at this equation, there's not any whole number that can be divided into 4. Remember, just x means 1x, 1 and 2. There is not any number that can be divided into those evenly. So for that reason, this is a prime polynomial. The second definition is being factored completely. Factored completely. All right. Now, being factored completely means that when you see an equation like this, if you can take something out, if you can factor it, and factoring it goes back to chapter 1, if you can factor and make it a true statement, then you need to do it till you need to continue factoring until you get down to a prime polynomial. All right, so another example for factored completely is going to be x plus 1 times x plus 2 times x plus 1. Now, that is factored completely, but if you saw it, this same equation, like this, because this right here is equal to these two smaller polynomials, then this would not be factored completely. So anytime it says to factor completely, we want it to look as much like this as we can. Then the last definition is going to be factor by grouping. Now, in factor by grouping, just like what we think of when we think of a group, that means you're going to combine people into, you're going to combine the equation based on something in common. All right, so the factor by grouping could be, if we wanted to say, an example could be 3x plus 3 minus 2x plus 2. Now, in factor by grouping, we see that right here, these two have something in common. So we can now put a parenthesis, and these two have something in common, so we can put another parenthesis. Now we have grouped into two portions that are the same. Now, this brings in factoring, because what is in common here is our 3, and so that means we can divide 3 and we can bring it outside the parentheses, And now, when we divide all of this by 3, it leaves us x, because 3x divided by 3, the 3's out here because that's our division, and then x is left because we just cancel out. 3 divided by 3 gives us 1. On this side, the same thing. What is in common is the 2. We divide by 2. And so now I can pull out 2 divided by 2. And I'm going to say minus. I've got my 2. And then I have x is left. And then again, 2 divided by 2 is my plus 1. Now in this situation, because I have an x plus 1 and an x plus 1, then I can rewrite and say 3 minus 2 times x plus 1. This right here is what we're going to focus on right now. The first example that I'm going to do is factoring by grouping. All right, as you can see, we have 3 in this equation. 3 have r's, but all of them don't. And so what we need to do is group anything that's in common. Well, I see that I can do an r cubed and an r squared because this r cubed it's the same as saying r squared times r. And so I can say, okay, well, because there's an r squared in this r cubed, and there's an r squared here, I have something in common. And so why don't I go ahead and rewrite, and now I have, that's my group. So you can see the r squared and the r squared. And then I have between 6 and 18, I can take 6 out of 18. And so I can go ahead and group 6r minus 18. From there, remember, I want to divide out what's in common. So I have an r squared and r squared. So I'm going to divide out the r squared. When I divide it, that means it goes on the outside of my parentheses. When I divide this, that means all 3 are canceled, and what is left is my r minus 3. On this side, I know you have to look to see the biggest number that you can take or divide both numbers by. And so 6 is, you can take 6 out of 18, and so I can go ahead and say, okay, well, let's divide by 6. All right, so again, when I divide it out, it goes on the outside of the parentheses. And then 6 divided by 6 gives me 1, so I'm going to put 1r. And then 18 divided by 6 gives me 3, so minus 3. Now, what we do is see if there's anything in common. Because if there's not, then it has to be left. But I can see that I have an r plus minus 3, and remember, just an r means 1r, r minus 3, and 1r minus 3. So if they're the identical same set of parentheses, then you can list it one time, 1r minus 3, and then the 2 outside the parentheses now can go inside its own parentheses. And you have completed factoring by grouping. All right, for this equation, they want us to factor completely. The first thing we need to do is see if there is anything that all 3 portions of this equation have in common. And so I have to look and say, okay, well, I have a 3, and 18 can be divided by 3, and 24 can be divided by 3, so I know that they have at least one thing in common. So I'm going to do that first. Remember, I divide by 3. When I divide by 3, I'm going to rewrite it with the 3 being on the outside of an equation. And so I can say, well, 3 divided by 3 gives me 1. 18 divided by 3 gives me 6. And then 24 divided by 3 gives me 8. And all I did was bring down all my x's. All right, now what we're going to do is look to see how many x's are in common. So I see that the lowest x is 2 because it's squared. So that means that each of these others have at least 2 x's. So again, I can divide by x squared, and I'm going to bring that out, 3x squared now, because when you divide, you bring it on the outside of the parentheses. Now, if I take 2 x's away from here, remember the quotient property of exponents, so I'm going to subtract 2, so that gives me x to the 6th. From here, subtract 2, and that's going to give me 6x cubed. And then subtract 2 from here, it leaves me with just 8, because it technically is to the 0 power, so this is 3. And anything to the 0 power is 1. So that's why we have just 8. Now, what we have to do at this point is look to see if we can factor this out anymore. And what we will do is we'll look and see that the factors of 8 are 1 times 8 and 2 times 4. All right? We need to find which one of those is going to equal 6. Well, if I do 1 times 8, it gives me my 8, but 1 plus 8 gives me 9. So that lets me know that's not 6. So I can look at 2 and 4. I have to look and say, okay, well, if I want to do x plus 4 and x plus 8 plus 2. I'm looking at the wrong thing. Plus 2. Now, I have that part done, but I've got to get to my cubed. All right? So I need to look here, and do I want to say, if I have x squared here and then x cubed here, is that going to get us, x cubed and x cubed. X cubed here and x cubed here. Remember, because 3 plus 3 gives us 6. So we can say 3x squared. And then here is our factor. Because when you want to check your work, the way to know that you've got the right answer is you can check it by saying x cubed times x cubed. That becomes x to the 3 plus 3. And then I have x cubed times 2 gives me 2x cubed. And then 4 times x cubed gives me 4x cubed. And then 4 times 2 gives me 8. When I combine like terms, that becomes x to the 6th plus 6x cubed plus 8. So because this matches this is our factor completely.